In this video, we are going to run the simulation called Wave on a String. In this simulation, there will be a string which we can wiggle the end to make waves. We can also adjust the frequency and the amplitude to produce different results. Another thing we can change is the tension. We also have the choice of the end being fixed, loose, or open. By changing these factors, we can learn more about and get a better understanding of waves on strings. Let's get started. For our first scenario, we will choose a selection of fixed end. Now, let's make sure that our damping is on 0 and that our tension is the maximum that it will go. Let's make a wave by wiggling the end, as you can see me doing now. We see that the pulse reflects off the fixed end and comes back on the opposite side. We see that this continues on, and it will continue on forever because of our damping being on 0. If our damping were to be raised to, say, 40, we can see that the wave eventually dampens and comes to a stop. For our second scenario, we will switch our mode to oscillate. As we switch to oscillate, we see a new box appear at the top with many options. In oscillate mode, we have the option to change the amplitude, frequency, damping, and tension. We have the opportunity to change these variables because in oscillate mode, we send a train of waves down rather than just a single wave like in the previous scenario. Let's recall that velocity is a function of the medium. When dealing with the wave on string, you can change the medium by changing the mass of the string or the tension of the string. In our simulation, we can only change the tension of the string. Watch what happens when we put the tension a little higher. We see the wave gets faster, yet the frequency remains unchanged. If we put the tension even higher, we see the wavelength gets longer and the speed gets faster. Now let's drop our tension lower. We see the speed decrease significantly. This is because the greater the tension is, the greater the speed. When we lower the tension, we are also lowering the speed. Now, let's select pulse mode. Also, let's choose loose end. Let's also put our damping to 0 so that the wave will continue on and not die out. We will also raise our amplitude and pulse width a little so that we can see the wave a little better. Now let's send a pulse. We see that the wave reflects back on the top side, or where it came across and started from. This is because we chose the selection loose end. With a loose end, the pulse can move the end with it up because it is not tied or stuck in place, like with a fixed end. Now we just saw that when it came back to its starting point, the pulse reflected back on the bottom side. This is because the starting point is a fixed end rather than a loose one. Now when the pulse hits the loose end again, it traveled back the same way it came. Now, when it's going to hit the fixed end again, we see it reflect back to the other side.